is where we left off last video. We were working on the speed timer, and we had filled it in a little bit so that we could test out the beacon that sends us the number, which is going to be either 0 or 1 for starting line and finish line. But we have them as constants so that we understand what we're talking about when we look at the code. Okay, so let's look at how are we going to determine when the starting line has been crossed or the finish line has been crossed. And what we're going to do basically is find the maximum signal strength for each time we receive one of these messages. And the radio can do that. It has signal strength right there. So let's create a variable to hold on to it. We're going to call it strength. Hopefully we'll call it strength. Oh, there it is. That looks right. And we're going to put it at the top because we'll need it no matter what. Whether it's a starting line or a finish line, doesn't matter. And we're going to need some variables now. We need 4 of them. Now we could use 2 arrays, but I'm going to use 4 variables. There's going to be some duplicated code, but I'm okay with that. So what we're going to need is a start, max strength, and we're going to need a start time. We're going to need a finish, max strength, and we're going to need a finish time. And what these are going to hold is the signal strength, the maximum signal strength we've received so far, and the clock time when we receive that max strength. Okay, so we need to find that. So let's do some logic. So if logic, let's pull that over. If the strength that we just received is greater than the strength that we've been keeping track of, which is start max strength, then our start time is going to be equal to our running time. Where are you, running time? Running time in milliseconds. So when the microbit is started, as soon as you power it up, it starts counting in milliseconds. And this is how many milliseconds it's counted. So this is the number of milliseconds since we powered up the microbit. And we don't need the actual time. We just need to know the difference between the two, and we can just subtract the one we got when we started and the one we got when we hit the finish line, and that's the difference. Okay. And we also need to save our new maximum. And we want to set that to the strength that we just got. And we'll toggle this bit every time we get a message. That's good. And we're going to essentially do the same thing, except this will be finish. Finish max strength, finish time. Where are you? Finish time, there you are. And finish max strength. And we're going to toggle that. Okay. So now we got some initialization to do, because obviously these need to start somewhere. So initialization. Start time. We're going to set that to 0, because it's impossible for it to be 0 if it's working properly. If we've made a mistake and we haven't gotten a start or a stop time yet, we'll know because it's still a 0 from when we initialize it. So finish time, start time, finish time. And we're going to need another constant. And in this case, it's going to be min radio signal strength. The minimum radio signal strength that we could possibly ever get is going to be a negative 256, because negative 255 is the lowest that number of bits can be. Now we can go ahead and set our finish max strength to be minimum radio signal strength. And we also want the start max strength to be the minimum possible, so that whenever we get one of those, we know it's going to be bigger and it's going to set the time. Each time we get a bigger one, a bigger strength radio signal, we'll set the time again. And when we finally get through past both of those beacons, we should have a start and a stop time. Okay, so now we've got to implement our protocol. And as you may recall, our protocol consists of receiving a message, a string. And let's get our logic, because we're going to be receiving either a start or a stop message. And those are going to be strings. We're going to compare them. So, is the received string equal to the start message? Or is the else if, is it equal to the stop message? And I don't really need to do anything else if it's not one of those two. If I receive a message that isn't one of these two, I'm not going to do anything with it. I'm just going to ignore it. So we need to do some initialization. And we put a lot of our initialization up here when it really needs to be down there. So let's move it. So when we receive start, we're going to set the start time to 0, finish time to 0, and finish strength and start and finish strength. Oh, let's make it start and finish. Minimum radial signal strength. Okay, and one last thing we need to do. We need to acknowledge that our dog timer is running correctly. And just like with the beacon, I want to show a check mark. Okay. Now, when we receive a stop message, what do we need to do? Well, first thing I want to do is I want to check to see if we have the data we thought we would get. And so I'm going to have several conditions to meet. And let's see what those conditions are. So one condition, I need the start time to be greater than 0. Now you may recall we set it to 0 when we started. If it's still 0, we did not get a start time properly, and that's not good. What other conditions? Well, it's not just the start time, it's also the finish time. So if either of those are 0, no good. One more thing. We want the start time to be less than the finish time. That kind of tells us that we ran through the start before we ran through the finish. And that's going to be a good thing to know. So we need to put those together logically because they all return true or false. And I want them to all be true. So I'm going to create 3 spots for them. 1, 2, and 3. And because they're all ANDed together, they must all be true for us to execute this. If they're not true, then what do? I'm going to send a string, and that string will be an error message. We set that up in our protocol. And I also want to indicate that on the microbit itself. Okay. As long as we're at it, let's also put an icon in here when we turn it on, and we'll use the happy face. And here, if we get all the way to the end of this, we want to show a happy face as well. Now, here's where we need to do our calculation. We've got a start time and a finish time. We need to do the calculation. So I'm going to create a variable. First thing I want to calculate is the amount of time in lowercase. It's not a constant. Amount of time in seconds. And how do we do that? Yeah, we start out with a set, time in seconds. And math-wise, it's going to be a difference. And the difference will be, because the finish time is larger than the starting time, we'll subtract the start time from the finish time and get a positive number of seconds. But that's not milliseconds, but that's not seconds. We need a conversion. So let's create a variable that does that conversion for us. And it's going to be seconds per millisecond. I'll accept that correction. And we need this here. And how much is it? Well, it's going to be 1 second for every 1,000 milliseconds. So it's 1 to 1,000. So now we can do the conversion. So we're going to take our difference and we're going to multiply it by our conversion factor, seconds per milliseconds, and that'll give us our time in seconds. Okay, now we need to calculate feet per second, I think. I can get that. Oh, I've missed something, haven't I? How do I know how many feet our dog has run? Okay, I'm going to need another variable. And it's going to be lowercase. So distance in feet. And I'm going to start that out as 3. And I need to be able to change that because when I go outside and I measure the distance between our 2 beacons, I might need to adjust that. So if I push the A button, I want to change the distance in feet by a -1. And I want to display what that number is. Oh, it's right at the top. Of course it is. Distance in feet. And if I push the B button, let's do it this way. Sneaky. Then I just have to change that to a 1 and change that to B. I'm going to increase it by 1 foot and show the distance in feet. Now, when I go out to the backyard, I'll push the A and B buttons and enter how many feet it is between the 2 beacons. So now we can calculate our speed in feet per second. Put it in there. And how do we know that? That one's fairly straightforward because we've already converted to seconds. So this is going to be our distance in feet divided by our time in seconds. Where are you? Time in seconds. That's feet per second. Now, though, I'd really like to have speed in miles per hour. Speed miles per hour. And we're going to need a conversion for that. So I'm going to need another variable. Catch that. And this is going to be feet per second to miles per hour. And I can calculate that out, or I can look it up with Google. It's 0.681818. That is simply 1 foot per second times 60 seconds in an hour. 60 seconds in a minute times 60 minutes in an hour divided by 5,280 feet in a mile. And that's the number you get. So now we can multiply feet per second by our factor. So speed, feet per second, times feet per second to miles per hour gives us speed in miles per hour. And now we want to send that. No, I don't want to receive it. I said I want to send it. And we've already set up our protocol. We know what the speed message should be. So the name. And we are going to send the number speed in miles per hour. And then we're going to show our smiley icon, meaning, hey, we did it. Now, the speed in miles per hour can be quite a long number of digits. And I don't really want that many digits. So I'm going to go ahead and truncate it a little bit. And the way I'm going to do that is I'm going to have something called I'm not mean to shout it, 2 decimals. And given an amount, I will return that with only 2 decimal places. So how does that work? We need a return. And what we're going to do, we're going to do a little bit of math. We're going to take our amount, going to multiply it by 100. What that's going to do is it's going to take the first 2 decimal places and make those part of the integer amount. It's going to move that decimal place over. We're then going to round that so that it drops off the fractional part, the decimal places. And then that. We're going to divide it by 100 to put the decimal place back where it belongs. Now I can use that function so I can take out a couple of the decimal places so that it only have 2 decimal places. And that seems about right. Given we're not we don't have enough accuracy really to even support 2 decimal places, let alone a dozen decimal places. So rounding it to 2 is already stretching it. 1 decimal place maybe, because we're only sending our signal back once every 10 times per second. So we're already stretching a little bit. And that seems to be about right. This is getting quite long, so I'm going to stop here and we'll test it in the next video. All right. Thank you for watching.